So as you can see, I have the expect assertion library already installed on this JS bin, and we have a couple lines of code in our JavaScript that we're going to be refactoring. So here we have a function called SumOdd, and it is doing an iteration here. It's essentially adding all of the numbers in this array that have a num mod 2 of 1, meaning that they're odd numbers. And so here we have our SumOdd of these, and this will equal 9 because that's 1 plus 3 plus 5 is 9. And if this doesn't throw an error, then we're going to get a log that says passed. So if we run this with command enter, then we'll see that we have passed. So rather than just deleting this entire function and starting from scratch, it's nice to be able to compare the two. And so I'm going to create a brand new function called SumOddReduce, and that's what it will be called until I've completely refactored this. So here we'll simply return array.reduce, and the reduce function takes a couple of parameters. First is a function, and we're transpiling it with Babel here, so that can be an arrow function. The first argument to this function, this callback function, is an accumulator, and our accumulator makes sense to be called total. And then the next argument is item, and in our case, it's going to be num. And then we'll return what it is that we want for the total to be. And so we'll write that function here in a moment, but next we're going to specify 0 as our initial value, just like we do up here where we said let total equals 0. That's going to be the initial value that is passed into our reduce callback. So now we're going to flesh out the function here. We're going to basically do the same logic we do in this for loop in our reduce function. And so because we already have the num that's being passed to us in the reduce, we don't need to do that again, but we can take this if statement and stick it in right here. So here, instead of just adding numbers to our accumulator, we're actually going to be returning what it is that we want our accumulator to be based off of this iteration. And so in this scenario, we want our accumulator, our total, to be the total plus the number. And so that is what's going to be passed into the next iteration and ultimately returned from this reduce function. So if we were to just go ahead and add SumOddReduce here, we'll just copy this and change this to SumOddReduce. We're going to get a failure, and that's because we expected nan to equal 9. And the reason that happens is because when this case fails, what we're actually returning is undefined. And so the next time it comes around, it's going to say the total is undefined, and now we're adding undefined to a number. And so we always need to make sure we return what we want the next iteration of this reduce function to accept, even if we don't alter that or make any changes to it whatsoever. So now if I run that, we're going to get everything passed. And now if we compare these two functions, this one has a bunch of state that it has to manage on its own by declaring these variables. It has this for loop that has this interesting syntax, which you're used to if you're an experienced programmer, but its imperative style is a little bit harder to think about. And especially with some of the issues with for loops, it just makes it a little bit more imperative compared to this more declarative approach. However, we're still doing some logic in here that may not be totally straightforward, and there's a way that we can actually refactor this further to make it a little easier to understand and a little bit more declarative. So basically what we want to do is we only want to apply this logic right here. This is the logic that actually matters. We only want to apply this to the things that are odd. And so we can actually do a filter function here first to filter out anything that doesn't satisfy this condition. So we could say that we'll accept a num, and we'll say only take the things where num mod 2 is equal to 1. And now we can get rid of this logic here and turn this into a one-liner arrow function. And now we have two one-liner functions here. If we run that again, we're going to get that it passed. We'll do another exclamation point just to make sure that works. And now we see that we have an array that is first filtered down to only the things that are odd, and then reduced to the sum of all of those numbers in that array, starting at 0. And so now, with both of these functions accomplishing the exact same thing, we can get rid of this function altogether and rename this one to the same as the old and get rid of that. And now things look much cleaner. It's a lot easier to understand in a kind of a declarative fashion what's going on with this sum odd function.